Alright, Jordan, we got example 9.4. Just go ahead and move this just a little bit so we can see the question. Okay. Two men are standing back to back and fire arrows in opposite directions. One arrow travels 350 feet per second and the other arrow travels at 425 feet per second. What is their relative velocity? Well, the relative velocity is going to be somewhat, when we go over the first example, it'll become a little bit more apparent, but it has to do with the perspective. And in this case, we're kind of taking it from a third-person perspective, or you can actually take it from a perspective of one of those two men in this problem. So, whichever way, it doesn't really matter. We're just trying to figure out how fast the things that are moving are either going away from each other or coming towards each other. So in this case, I like to draw a picture most of the time. It helps me understand it a lot better, and I think it's going to help you guys understand it a lot better. So I'm just going to do this, and this is going to represent the motion of the arrows. And I know that they're traveling away from each other because it says so in the problem. Two men are standing back to back and fire arrows in opposite directions. Okay, so that's how I get the arrows pointing away from each other. You can even draw little stick figures if we want and make it a little bit more or less interesting. And we have one arrow travels 350 feet per second. And another arrow travels 425 feet per second. Okay. When two things are traveling away from each other in opposite directions, we add those velocities together to get the relative velocity. And this is what we came up with for our little cheat sheet. The velocity is equal to the speed and the direction, so it's just the speed. In addition, we have a direction that's associated with that. So, whenever things travel towards each other, we add them. Whenever they travel away from each other, we add them. If they're traveling in the same direction, we subtract them. And I'll kind of explain that a little bit better in either in class or in the next example. So, I'm just going to go ahead and, I don't think there's a good spot to leave this, but I'll just leave it up here just for another couple seconds so you can see it. Okay. So since these are traveling away from each other, we're going to add them, because it's how fast are the arrows traveling away from each other. So, we have the simple 350 plus 425. 775. So we have a velocity of 775 feet per second, but they're traveling away from each other, so we have to put that in there. Otherwise, it's just the speed, not a velocity. So we have 775 feet per second away from each other. And that's going to be your answer. The key again with velocity is you always want to have a direction associated with the speed.